Hello guys, in previous lecture we will study the acidic character or acidic nature or acidic strength of alcohol. In this lecture we can properly or exactly we started the reactions of alcohol. In this point, the first point is the reaction of alcohol with Grignard reagent. The reaction of alcohol is in with Grignard reagent. We know what is meant by Grignard reagent. Okay, the Grignard reagent is commonly denoted by RMgx. Okay, or this Grignard reagent is also known as a organometallic compound. It is also known as a organometallic compound. Okay, in this Grignard reagent, it is a RMgx. Commonly, it is known as a alkyl magnesium halide. It is commonly known as a alkyl magnesium halide. In that, this Grignard reagent is prepared by using alkyl halide and magnesium metal. Okay, this metal is included added in between R alkyl group and halogen atom. Then this halogen shows the electronegativity. Therefore, this is a partial negative charge. This magnesium shows the partial positive charge, and this alkyl group shows also partial negative charge because this alkyl group is directly attached to the magnesium atom. Magnesium shows the partial positive charge. Therefore, this alkyl group shows the partial negative charge. Okay, it is commonly known as a alkyl magnesium halide. This alkyl magnesium halide is reacted with alcohol. There is a ROH. It is reacted with Grignard reagent RMgx. It is also known as alkyl magnesium halide. In that, alkyl group shows partial negative charge, magnesium shows partial positive charge, and this halogen also shows the partial negative charge. In between, the bond between magnesium and halogen, it is a purely ionic bond because the electronegativity difference in between magnesium and halide, it is a large. Therefore, the bond between Mg and X, it is a ionic bond. The bond between R and Mg, alkyl group and magnesium, it is a partially ionic and partially covalent character is shown. Okay. Now we goes towards the alcohol. In that alcohol, oxygen carries lone pair. Therefore, it attracts the shared pair of electron from hydrogen towards itself. Therefore, this hydrogen is in partial positive charge. This oxygen shows the partial negative charge. That means the alcohol is in acidic nature. Therefore, it donates the H plus ion to any electron rich species. Okay, this acidic character we show in previous lecture. Okay, therefore these alkyl groups attacks on this acidic hydrogen or H plus ion. By abstracting the H plus ion, then it gives this R and this H is combined with each other, and there is a formation of alkane. Okay. Then this alkane is also commonly known as a hydrocarbon. Okay. The remaining part, then after elimination of H plus ion, then it remains the RO minus. There is a alkoxide ion. This alkoxide ion again attacks on the electron deficient magnesium atom because the bond between alkyl group and magnesium, it should be breakdown, and this alkyl group combined with hydrogen atom, there is a formation of alkane. Okay, after formation of alkane, this alkyl group withdraws this shared pair of electron, or by using this shared pair of electron, this alkyl group bonded with hydrogen atom, and after breaking of bond between alkyl group and magnesium ion, this magnesium shows the complete positive charge, and after breaking of hydrogen bond with oxygen atom, then this oxygen shows the completely negative charge. Okay, therefore the remaining part, that is a alkoxide ion, this is a magnesium plus, this alkoxide ion attacks on the magnesium, then it forms MgX, and this is the formation of OR. Okay, then most of the important point is that when Grignard reagent, important point is that when Grignard reagent is reacted with acidic hydrogen, that means that reacted with the compound which contains the H plus ion or the compound which donates the H plus ion, then alkane is formed. Okay, then this is a main reaction. When alcohol is reacted with the Grignard reagent, then it forms their hydrocarbon, that means then it forms the alkanes. Okay, this is the most important reaction. Okay, this Grignard reagent and alcohol reaction, for better understanding, we can take some examples. The first example we take here, when ethanol is reacted with C2H5 MgCl, halogen will be replaced, X is replaced by chlorine, bromine. Okay, any halogen it should be used here. Then C2H5OH plus C3H7 MgBr is here. Okay, this reaction is carried out. Okay, this is a ethyl magnesium chloride, and this one is a propyl magnesium bromide. Okay, then from this Grignard reagent, the magnesium shows the partial positive charge, halogen as usual shows the partial, as well as alkyl group also shows the partial negative charge. From this alcohol, this is a methanol. From this alcohol, the hydrogen is present in acidic nature. Therefore, this hydrogen is present in H plus form. This alkyl group attacks on this H plus ion, and there is a formation of respective alkanes. That is a CH3. There is a formation of ethane. The remaining part, that is this methoxide. After elimination of H plus ion, the oxygen shows the negative charge. This negative charge oxygen attacks on the magnesium, and there is a formation of MgOCH3 and Cl. Okay. Then another example is that this is a propyl magnesium bromide. This propyl magnesium bromide containing this alkyl group shows the partial negative charge. From this ethanol, the hydrogen present is acidic in nature. Therefore, this propyl group, that means this carbon is attached on this hydrogen atom, and there is a formation of propane. And then remaining part, there is a alkoxide ion is attached on the magnesium, and then it forms a product, that is CH3, CH2, CH2, or it is directly, we can also write in this form, C3H8. This is a propane, and the remaining part should be attached. This alkoxide ion attacks on the magnesium. There is a magnesium. This is a ClOC2H5 is formed. Okay. Then another example is that is reacted with methyl magnesium chloride. Okay, this methyl magnesium chloride, from this methyl group attracts the H plus ion, then it forms the CH4. It forms CH4 plus the remaining part, that is MgCl. That is this is a negative charge oxygen atom. It attacks on the magnesium ion, then is formed OCH, 2CH, CH3, and CH3 is here. Okay. From these some examples, we know that the preparation of hydrocarbon or hydrocarbon is formed when alcohol is reacted with Grignard reagent, then it forms hydrocarbon. Okay, but this hydrocarbon or the product, it may be noted that the product, it may be noted that the alkanes are formed, the most important point, that is a note, the alkanes are formed, corresponding to alkyl group of Grignard reagent. That means the alkane, the product of this hydrocarbon, is totally depends on the which alkyl group is attached to or which alkyl group is present in Grignard reagent. Then this Grignard reagent corresponding carbon atoms, it forms or it generated the respective or corresponding hydrocarbons. Okay. Therefore, this is the most important point. In this point, the product, it may be formed, or the this note is important. The product, it may be formed, that is a alkane or hydrocarbon. Then the alkanes are formed corresponding to alkyl group of Grignard reagent, which is totally depends on the which type of Grignard reagent, which alkyl groups is attached to the Grignard or present in a Grignard reagent. Then this Grignard reagent containing alkyl group, it forms their corresponding alkane. This is the most important points. Okay. Then in this case, in this alcohol, there is a acidic hydrogen is present, but in some another functional groups we also studied which contains the acidic hydrogen. Okay. That means the reaction of Grignard reagent with functional groups which contains acidic hydrogen. Okay. Then this point is important for GE as well as NEET exam. Alcohol is also included in this point. Okay. Then firstly we consider the water. In this water, the hydrogen atom is directly attached to oxygen, therefore oxygen attracts the shared pair of electron towards itself, therefore this hydrogen present in the form of H plus ion, therefore this hydrogen is present in the form of acid. Okay. This hydrogen shows the partial positive charge, this hydrogen shows the partial positive charge, and this oxygen shows the partial negative charge. Okay. In second example, we can also take the alcohol. In case of alcohol, in case of alcohol, the oxygen also shows the electronegativity. Due to this electronegativity, it attracts the shared pair of electron towards itself from the hydrogen atom. Therefore, in case of alcohol, the hydrogen is present in H plus form or is present in acidic in nature. Then the hydrogen halide, this is a HX. Okay, we write here in this form, this hydrogen. The halogen carries lone pair, and due to the highest electronegativity of halogen, it attracts the electron. That means in case of hydrogen halide, the hydrogen is present is in acidic in nature. This halogen means fluorine, bromine, iodine. Okay. Now this functional groups are reacted with Grignard reagent. And this Grignard reagent shows partial negative, partial positive, and halogen also shows the partial negative charge. Therefore, this alkyl group attacks on this hydrogen atom of water. This alkyl group attacks on the hydrogen from alcohol. This alkyl group attacks on the hydrogen from HX. Okay, then it forms forms their respective hydrocarbons, but the hydrocarbons which is totally depends on the alkyl group which is present in Grignard reagent. This Grignard reagent containing alkyl groups forms their corresponding alkanes, then it forms the RH. Okay, the negative part remains as it is. This negative part, that is OH minus, OR minus, X minus, is combines with MgX, then it forms the another or adjacent product. Okay, these are the three examples or three compounds which are taken here. Then after that we also consider the another functional groups which contains the acidic hydrogen. Then another functional groups contains the NH3. NH3 is written in this form. Okay, in this NH3 ammonia, the nitrogen carries lone pair. Due to this lone pair, nitrogen abstracts the electron from the hydrogen towards itself. After that, there is a formation. There is a carboxylic acid. Any carboxylic acid here it should be used. After that, there is a amine RNH2. This is a amine. This one is a primary amine. This one is a secondary amine. But tertiary amine does not reacted with tertiary amine does not reacted with Grignard reagent because absence of acidic hydrogen, that is absence of H plus hydrogen. Okay. In case of tertiary amine, the structure of tertiary amine is R. Three alkyl groups are attached to nitrogen atom. Here the H plus ion is also absent, therefore the tertiary amine does not reacted with Grignard reagent. Therefore only primary and secondary amine it should be reacted with Grignard reagent. Okay. In this carboxylic acid, this is a carboxylic acid. In this carboxylic acid, the hydrogen is attached to strongest electron withdrawing out strongest electronegativity oxygen atom. Therefore, this hydrogen donates the electron to oxygen. That means the hydrogen present is in form of H plus ion. This nitrogen also carries the lone pair. Therefore, it abstracts the electron from the hydrogen towards itself. This is also present in H plus. Then the secondary amine also contains the H plus ion. This hydrogen it donates the electron to the nitrogen. Therefore, this hydrogen present is in form of H plus. Okay, these three functional groups are reacted with Grignard reagent. This is the Grignard reagent. This is a partial negative charge. This magnesium shows partial positive, and this halogen also shows the partial negative charge. This hydrogen is in H plus form, this is also H plus, this also H plus, and this is also H plus form. Therefore, this functional groups contains the H plus ion. Therefore, this alkyl group attacks on the H plus, attacks on this H plus, attacks on this H plus, and it also attacks on this H plus of secondary amine. Therefore, this alkyl group abstracts the H plus ion from ammonia. It also abstracts the H plus ion from carboxylic acid. It also abstracts the H plus ion from the primary amine, and it also abstracts the H plus ion from the secondary amine. Therefore, this hydrogen is combined with alkyl group, and this alkyl group generates the hydrocarbon which is corresponding with alkyl group present in a Grignard reagent. Then it forms RH. And the remaining part, the remaining negative charged part, which is combined with MgX. Okay. And then in case of amine, there is a MgX NH2 is formed. This is the first. In case of carboxylic acid, there is a MgX, that is a OCR is attached here. In case of primary amine, there is a MgX, NHR is attached here. In case of secondary amine, there is a MgXN. R is attached to the magnesium. This is a remaining part of negative part is attached with the magnesium, then it forms their respective products. But important product is A, when any functional group which contains the acidic hydrogen is reacted with the Grignard reagent, then it forms the alkane. But this alkane, the alkanes are formed corresponds with alkyl group which is present in magnesium Grignard reagent or alkyl magnesium halide. Okay. Now we also consider some another examples or another functional groups which contains the acidic hydrogen. Okay. By taking some example, this is the CH3 CHOH CH3. This is a CH2OH. This one is a CH3C CH3 OH, and this one is a CH3. It is a primary carbocation, primary alcohol. This one is a secondary alcohol, and this one is also tertiary alcohol. It is reacted with C2H5 MgCl. Okay. This is a ethyl magnesium halide. This ethyl magnesium halide is commonly known as the Grignard reagent. Grignard reagent is a organometallic compound. Therefore, because in this reagent the metal it should be present. Okay. Then this hydroxyl group is written in this here. Okay. We know that the hydroxyl group or alcoholic functional group which contains the acidic hydrogen or which contains the hydrogen is in acidic form. Therefore, this H plus, this H plus, this H plus form primary, secondary and tertiary, respectively primary, secondary and tertiary alcohol. This H plus ions, it should be combined with the ethyl group. Then it forms their respective alkane, that is C2H6. There is a C2H5. After addition of one hydrogen, there is a formation of C2H6 plus remaining part. This remaining part is attached with magnesium and Cl. There is a formation of hydrocarbon or there is a formation of alkanes. Okay. When that means the Grignard reagent is reacted with primary alcohol, secondary alcohol, and also it is reacted with tertiary alcohol. Okay. Then after that, we consider one of the most important reaction of Grignard reagent with functional group which contains acidic hydrogen, that is R C triple bond C H. This is a terminal alkyne. This is a terminal alkyne. Terminal alkyne means this alkyne terminal end of the compound. Okay. It is commonly known as a terminal alkyne. It is reacted with Grignard reagent. Okay. Here we take the R dash. Okay. Then this alkyne group is also contains the H plus ion, or this alkyne group, that is terminal alkynes which contains the H plus ion. Then how it is possible? In this functional group, the carbon-carbon triple bond is here. The carbon-carbon triple bond, the triply bonded carbon atom which contains the sp hybridization, according to S character percentage. In sp hybridization, there is a 50% S character. In this also 50% S character. Then according to S character percentage, if the S character percentage goes on increases, the electronegativity of that unsaturated carbon which should be goes on increases. Okay. Here in sp hybridization there is a 50% S character. In this triply bonded carbon atom, the hybridization of triply bonded carbon atom, it is a sp. Then it shows a 50% S character. Then S character percentage is a higher than sp2 and sp hybridization. Therefore, this triply bonded carbon atom which shows the electronegativity, it is a greater than the electronegativity of triply bonded carbon atom, which is greater than doubly bonded carbon atom, and which is also considered the singly bonded carbon atom. Okay, but in this case, the according to S character percentage, these two triply bonded carbon atom shows the electronegativity. Therefore, this carbon atom, it attracts the electron from the hydrogen atom, which is present in a bond formation, Therefore, after donation of electron, this hydrogen present is in acidic, or then it is present in H plus form. Okay, therefore this H plus form contains, we got the H plus ion. This hydrogen we got the H plus ion. Therefore, this negative charge alkyl group, which is present in Grignard reagent, this alkyl group attacks on this hydrogen atom or combined with hydrogen atom, and it forms their corresponding hydrocarbons or their corresponding alkanes, and remaining part it is combines with magnesium, that is Mg, C triple bond C, there is this, and this hydrogen it should be attached to magnesium. Okay, there is a formation of hydrocarbon. Okay guys, then this is some important examples to reaction with Grignard reagent. If any functional group which contains the acidic hydrogen and then it is reacted with Grignard reagent, then it forms the corresponding alkanes. The corresponding alkanes means which alkyl group is present in magnesium or which is present in Grignard reagent, then respective alkyl groups, it forms a hydrocarbons. This is the most important point, and these are some examples of the acidic functional groups and reaction with Grignard reagent. Okay, then after that, first example we consider the Grignard reagent for water. Okay, in case of water, water also carries the H plus ion. Therefore, it is reacted with Grignard reagent and it forms their corresponding alkanes. Okay, but in case these two hydrogen atoms are replaced by deuterium, that is, this is a D2O and this one is a H2O. This hydrogen is replaced by deuterium. Deuterium, it is an isotope of hydrogen. Deuterium, it is an isotope of hydrogen. That means this hydrogen is replaced by their isotope. Okay, deuterium, it is denoted by capital D. It is denoted by capital D. Once again, I will clear that the deuterium, it is an isotope of hydrogen. That means this hydrogen which is present in a water molecule which is replaced by deuterium, and after replacement of deuterium it is called as a deuterated water, or it is also called as a deuterium water. It is also known as a deuterium water, and after replacement of deuterium to hydrogen, then the molecular weight of deuterated water or deuterium water goes on increases. Therefore, this water is also known as a heavy water. This water is also known as a heavy water. Okay. Then this is a deuterium water. This deuterium water is prepared by using a water as usual. In this, once again I will be explained. The hydrogen atom is replaced by two deuterium atom. Deuterium, it is a isotope of hydrogen. Then it forms the deuterium water. And this deuterium water, it increases the molecular weight than the normal water. Therefore, it is called as a heavy water. Okay. Then it is also reacted with Grignard reagent. Okay. Also reacted with Grignard reagent. Then this deuterium is also isotope of hydrogen. Therefore, the characteristic of deuterium is quite similar with hydrogen atom. Therefore, this deuterium also donates the electron to oxygen. This also deuterium donates the electron towards the oxygen because oxygen carries the lone pair and it also shows the electronegativity. Therefore, this oxygen shows the partial negative charge, this deuterium shows the partial positive, and this one is also shows the partial positive charge. And this positive charge deuterium, and in this case of Grignard reagent, this alkyl group is a partial negative charge. The partial negative charge alkyl group is attacks on the deuterium and then it forms Rd. Then it forms the Rd. Okay. In this case, the alkane containing one hydrogen atom is replaced by deuterium, and the remaining part of is attached to the magnesium. Okay. Then this one is also known as a hydrocarbon because this deuterium is also isotope of hydrogen. Okay. These are some examples of acidic hydrogen containing functional group with the Grignard reagent. And the most important point in this lecture, it is a reaction of alcohol with the Grignard reagent. When primary alcohol, secondary alcohol and tertiary alcohol is reacted with the Grignard reagent, then it forms their corresponding alkanes, which depends on which type of alkyl group. It depends on the alkyl groups which is present in a Grignard reagent. According to this alkyl group, the corresponding alkanes are formed. Then after that, we saw some functional groups which contains the acidic hydrogen, and if acidic hydrogen is reacted with Grignard reagent, then it forms their corresponding alkanes. Okay guys, this is a most important point for JEE, NEET as well as CET exam. Okay.